Hello, and welcome. Today, we're diving into a really fascinating puzzle in the world of AI. How do you take these incredibly powerful jack-of-all-trades AI models and turn them into true, trusted specialists? We're talking about making AIs that are genuine experts in really high-stakes fields. Think medicine, law, you name it. Let's get right into it. So, it all starts with this question that might seem a little strange at first. We've got AIs that can write amazing poetry. They can code complex software. They can even ace graduate-level exams. So why then do they so often stumble when you ask them to do the nuanced day-to-day work of a real professional? Well, the answer comes down to something called the last mile problem. It's this crucial final gap between an AI's general knowledge and the super specific, nuanced understanding it needs for a particular job. You know, it's the classic difference between being a jack of all trades and a true master of one. At its heart, this whole last mile problem is really all about context. It's about somehow giving this powerful AI the deep, subtle understanding of a very specific industry's workflow. You know, all its jargon, its unspoken rules, the things you only know from being in the trenches. Without that context, even the smartest AI is basically just an outsider peeking in. Okay, let's make this real. Here's an example from healthcare. Now, you look at this question and it seems pretty straightforward, right? But believe it or not, this thing is a total minefield of ambiguity. This is exactly the kind of nuance where a general off-the-shelf AI model just falls flat on its face. So let's break it down. First off, what does unsuccessful therapy even mean? I mean, really, if the patient's pain gets a little bit better but it doesn't go away completely, is that a success or a failure? The answer to that isn't in some textbook. It takes real clinical judgment from an expert. And then you've got this term, conservative therapy. Sounds specific, but it's really not. In one situation, it could mean just physical therapy. In another, maybe it includes medication. A real expert knows which one applies, but an AI has to be taught to understand that context. And finally, what even counts as documentation? Okay, so if a clinical note says physical therapy started 8 weeks ago, but there's no update since, what do? Do you infer that it continued for the required 6 weeks? Or do you need a note that explicitly says treatment completed? You and I make these kinds of judgment calls all the time, but for an AI, that's a huge leap. So if the problem is this deep, this layered with nuance, then just throwing a bigger, more powerful model at it isn't going to cut it. The real solution isn't just a better AI. It's a better system that you build around the AI. And this, right here, is a huge shift in how we need to think about this stuff. So, instead of pouring all of our time and energy into just the raw horsepower of the AI model itself, the big breakthrough comes from shifting our focus. We need to focus on the intelligence of the entire system, a system that's designed from the ground up to capture and apply all those crucial real-world expert insights. And you know, as Christopher Lovejoy, who's both a medical doctor and an AI engineer, puts it, the company that wins in these specialized fields isn't necessarily the one with the fanciest AI model. No, it's the one with the best system for translating that deep expert knowledge into AI performance. That, right there, is the big idea. Okay, so how do you actually build a system like this? Well, it all starts with a really simple but incredibly powerful first step. You have to meticulously measure how, where, and most importantly, why your AI is failing. After all, you just can't fix what you don't understand. Now, this measurement process has two main parts. First, you have to define the one single metric that really matters to the end user. In this healthcare case, it's all about minimizing what they call false approvals. Second, you build what's called a failure ontology. It sounds complicated, but it's really just a detailed, structured map of all the different ways the AI can possibly mess up. And this is where it all clicks into place. Once you start tagging every single error with one of those failure modes, you can see exactly which problems are causing the most pain. It makes prioritizing a no-brainer. You can see right away, okay, failure mode A is the big one. Let's tackle that first and get the biggest bang for our buck. So once you know what you need to fix, the next question is, well, how? And this is where your human domain experts, your doctors, your lawyers, your engineers, they step into a new role. They become the AI's personal trainers. So even with really sophisticated models and tons of great engineering, the team working on this problem hit a wall. They plateaued. On this critical task, they got stuck at about 95% accuracy. Now, in a lot of fields, 95% is amazing. But in medicine, that other 5%, that's where all the risk lives. It just wasn't good enough. But then, check this out. After they put this system-first, expert-led approach into practice, they were able to push that accuracy all the way up to an incredible 99%. That massive leap from 95 to 99%, that is the last mile. And they didn't cross it with a bigger AI model. They crossed it with a smarter system. And here's why it works so well. The experts aren't just sitting there checking the AI's homework and saying right or wrong. No, they're actively reviewing the decisions, tagging the exact reason a failure happened, and then suggesting improvements, like new rules or new bits of knowledge that get fed right back into the system, so that same mistake never ever happens again. So when you finally put all of these pieces together, you don't just have a static program. You create something way more powerful, a self-improving loop, a kind of flywheel, where the AI actually gets smarter with every single case that it reviews. Here's what that 5-step cycle looks like day to day. Step 1, the AI makes a decision on a live case. Step 2, a human expert reviews it and tags any failures. Step 3, a product manager looks at that data and prioritizes which failure to fix next. Step 4, an engineer builds the fix. And then, Step 5, the improved system gets deployed back into production. It's this beautiful, tight loop that's always learning from the real world, guided by real experts. The real magic of this whole system is just how efficient that expert review step is. Think about it. In one single action, that one expert is giving you 3 critical things all at once. They're giving you your performance metrics, they're telling you which problems to prioritize, and they're literally suggesting how to fix them. That is an incredibly powerful feedback mechanism. So, you see, this isn't just some technique for healthcare AI. It's really a blueprint for building genuine expert intelligence in pretty much any field. And that leaves us with one final thought to chew on. Think about your own industry, about your own work. What complex, nuanced, last-mile problem is just sitting there waiting for a system like this to come along and solve it?